Hello and thanks for being here. I'm Juliane Zimmermann from the University of Cologne, and I would like to present our study Listeners and Lookers using pitch height and gaze duration for inferring mental states. First of all, I would like to say a few words about prosody and gaze for inferring mental states. Then I will present our study along with its methods, results, and discussion. Prosody can be used to infer mental states. For example, we can encode and decode new as opposed to given information by, for example, placing a pitch accent on a word that is new. We can also encode information in focus prosodically by doing the same. Emotional states can also be encoded and decoded prosodically. And because we can find all this information in prosody, we're also quite good at detecting lies based on prosodic cues. Gaze can be used in a similar fashion. For example, we know that gaze is often drawn towards things that are new, things that are important, or things that we like. So we look more often, but also longer at these things. And we can now use this cue to detect, for example, someone else's preference, but also if someone is lying, or for example, if someone wishes to interact with us. In our study, we wanted to understand better how prosody and gaze in combination can affect the perception of importance. And in particular, we wanted to know what is the influence of gaze duration towards an object and pitch height of a respective utterance on the participant's perception of importance of the object for another person, or in our case, for a virtual agent. Our hypothesis was that both higher pitch and longer gaze would lead to higher ratings of object importance. In our online study, we included 64 participants that were aged between 18 and 65. German was their only mother tongue. The task was the same after each trial, namely to indicate on a scale from 1 to 4, how important is the object for the figure on screen. We have 4 conditions in our paradigm because we combine our 2 factors, gaze duration and pitch height, and both have 2 levels. So on the left, you can see that gaze duration is either short, then it's 0.6 seconds long, or it's long, then it's 1.8 seconds long. And our pitch, so we only change pitch here, nothing else, is either comparatively low, then we have an utterance with an H star accent type, or it's comparatively high, then we have raised the peak of the pitch contour on the accented syllable by 45 Hertz. And thus we end up with the 4 conditions you can see here. And we will now look at 2 example trials, one from the short low condition and one from the long high condition. So these are basically the extreme conditions, you could say. And the other 2 are the mixture conditions in which either gaze or prosody is not supposed to increase the ratings of importance in comparison to the other level.
Der Toaster. Der Toaster.
Let us now jump directly into the results. So here you see the mean ratings across the whole sample. On the y-axis, you see the possible rating scale from 1 to 4. So 1 pertains to unimportance of the object. 2 means that the object is rather unimportant. 3 means it's rather important. And 4 means it's very important. On the x-axis, you see the different conditions. So the first one on the left is the condition in which pitch is low and gaze is short. And we can see that here the ratings are the lowest overall. And in the condition on the right side, which is the one in which pitch is high and gaze is long, you see that the ratings are in the mean, the highest ratings. So the mean is indicated by the diamonds. And in the middle, you can see the mixture conditions, which yield means that are in between. So basically here we see that we get what we expected. So if pitch is high and gaze is long, we can increase the ratings of importance of the object to the figure on screen. But we wanted to know if these results are statistically meaningful, so we ran a Bayesian ordinal model with the fixed effects, pitch height and gaze duration, as well as their interaction, and the factor word frequency because of its influence on word prominence perception. We also included random effects for the subject and the object. I highlighted here in bold font the effects that were statistically robust, and we can see that our two factors of interest, so pitch height and gaze duration, are statistically meaningful and they have comparable effect sizes, but their interaction is not statistically meaningful, and also the effect size would not be very great if it was. Word frequency has an effect, and this goes in the direction that words that are more frequent are also rated as more important here. We have random effects for subject and object that are statistically meaningful. And regarding the subject, we see on the one hand that the random intercepts are statistically robust effects. And this indicates that overall the subject have different baselines. So some subjects, for example, stuck to the lower end of the rating scale, whereas others use the whole rating scale. So yeah, they have different baselines in the first place, but they also take into account our factors differently, which is reflected by this random effect of pitch height and random effect of gaze duration. Yeah, but the random interaction effect is not statistically robust. We have a meaningful effect of random intercepts in our object effect, and this means that the objects differ in the mean regarding how important they were rating, and this is not so surprising because we have very different objects in the set. So they would also be assumed to differ regarding their general importance, and yeah, because we see that people differ regarding to what degree they take into account the two factors, pitch height and gaze duration. We wanted to know more about this, more about the individual behavior. So we ran a hierarchical cluster analysis on the coefficients we get out of this model. And you can see them plotted here. So here on the x-axis, you can see the individual coefficients for pitch height, and on the y-axis, you can see the individual coefficients for gaze duration that were produced by the model. And the single participants are represented by the squares, triangles, and dots. And the shapes, but also the colors indicate the clustering. And what this means is that, for example, someone very much to the right side of this graph, so for example, this blue dot would be a person that takes into account very much the pitch height. Because if pitch height is high, then they would rate that the object is very important, or rather important, to the person on screen, whereas gaze duration does not make a big difference in the ratings. And the same is true, but for gaze duration, if someone is very up on the y-axis, so for example, the green square far off on top, would be someone that takes into account more gaze duration than pitch height. We also see that some people cluster around 0, so these people do not take into account either Q for their rating. What's also interesting is that we do not see people that are taking into account both Qs to great extent. Now the clustering supports the idea that there are 3 clusters or 2 clusters, but we chose to illustrate the 3 cluster solution because first of all, it makes more sense because we can see that there are people taking into account one Q and then people that take into account the other Q and people that do not take into account either Q. but the second or the two clusters solution would simply be that the red and the blue group cluster together. So the leaders and the listeners. In our study, we could show that increased pitch height and longer gaze duration do actually increase the ratings of importance, which is in line with other literature that shows that pitch and gaze can be used as cues to infer mental states. In our study, we combined the two factors and saw no interaction effect. And this could mean that actually we have two isolated factor effects. And similar findings have been reported in studies that combined visual and auditory cues. But it could also mean that the effect is due to our methods and in particular to our instruction. And if you like, you can read more on that in our paper. We also found that there are clusters of listeners, lookers, and readers, or that's how we label them. And this could indicate that people concentrate on one of the two channels, which has also been reported in other papers, or if they do not concentrate on one of the two channels, that they take into account other aspects of the stimulus, like, for example, word frequency, or other aspects that we did not manipulate. This brings me to our references and to our team. On the left, you can see from the Department of Psychiatry, Kai Vogeley and myself, and on the right side from the IFL Phonetics Cologne, Martine, Grice, Francesco, Cangemi, and Simon Wehrle. With that, I leave you, and I thank you very much for your attention. Goodbye.